let's say that you are desperate for $1, and so you come to me, the local loan shark, and you say, hey, I need to borrow $1 for a year. And I tell you, well, I'm in a good mood. I'm willing to lend you that dollar that you need for a year, and I will lend it to you for the low interest of 100% per year. So 100% per year. So how much would you have to pay me in a year? Well, you're going to have to pay the original principal, what I lent you, plus 100% of that. So plus one other dollar, which is clearly going to be equal to $2. Now, you say, well, gee, that's a lot to have to pay, to have to pay back twice what I borrowed, and there's a possibility that I might have the money in 6 months. What kind of a deal can you get me for that, Mr. Loan Shark? And I say, oh, gee, if you're willing to pay back in 6 months, then I'll just charge you half the interest for half the time. So you borrow $1, and so in 6 months, I will charge you 50% interest. 50% interest over 6 months. This, of course, was one year. And so how much would you have to pay? Well, you would have to pay the original principal, what you borrowed, the $1, plus 50% of that $1. So plus 0.50, and that, of course, is equal to 1.5. So that is equal to, or $1.50. I'll just write it like this, $1.50. Now you say, well, gee, that's, I guess, better, but what happens if I don't have the money then? If I still actually need a year? And I say, well, we actually have a system for that. What I'll do is just say that, okay, you don't have the money for me yet. We can think about it, that I'll just lend that amount that you need for you for another 6 months. So we'll lend that out. We'll lend that out for another 6 months at the same interest rate at 50% for the next 6 months. And so then you'll owe me the principal, $1.50, plus 50% of the principal, plus 75 cents, and that gets us to $2.25. So that equals $2.25. Or another way of thinking about it is to go from $1 over the first period, you just multiply that times 1.5. If you're going to grow something by 50%, you just multiply it times 1.5. And if you're going to grow it by another 50%, you can multiply by 1.5 again. So one way of thinking about it is that 50% interest is the same thing as multiplying by 1.5. Multiplying by 1.5. So if you start with 1 and multiply by 1.5 twice, this is going to be the same thing. $2.25 is going to be 1 multiplied by 1.5 twice. 1.5 multiplied twice is the same thing as 1.5 squared. And you can see the same thing right over here. This is the same thing. 100% is the same thing as multiplying by 2, as literally multiplying by 1 plus 1. So this is multiplying by 2. So you could view this right over here. You could view this as 1 times 1 to the first 1 times 2, I should say. 1 times 2 to the first power, because you're only doing it over one period, over that year. And you say, hey, once again, where's that 2? Well, if someone's asking for 100%, that means over the period you're going to have to pay twice. You're going to have to pay the principal plus 100%. You're going to have to pay twice what you originally borrowed. If someone's charging you 50%, over every period, you're going to have to pay whatever you borrowed, so that's kind of the one part, plus 50% of it. So 1.5 times what you borrowed. So you multiply times 1.5 every time. And if you wanted to see how this actually related to the interest, you could view this as, so this right over here is equal to 1 times the interest part is 1 plus 100% divided by 1 period to the first power. And I know this seems like a crazy way of just rewriting what we just wrote over here, writing 1 plus 1, but you'll see that we can keep writing this as we compound over different periods. This one right over here, we can rewrite. We can write as 1 times 1 plus 100%. Here we took our 100% for the year and we divided it into 2 periods, 2 6-month periods, each of them at 50%. 1 plus 100% over 2 is the same thing as 1.5, and then we compounded it we compounded it over 2 periods. And actually, let me do that 2 periods into a different color. So the periods, let me do in this orange color right over here. And you might start to see a pattern forming. So let's say, well, gee, maybe I have the money back in, and you don't really like this because this is $2.25. That was more than the original $2. So you say, well, what if we do this over every 12 months? I say, sure, we got a program for that. So after every 12 months, after every month, I should say, I'm just going to charge you, 100% divided by 12 interest. So this is equal to 8 1/3%. And taking having to pay back the principal plus 8 1/3%, that's the same thing as multiplying times 1.083 repeating. So after 1 month, you would have to pay 1.083 repeating. After 2 months, and this isn't to scale, that actually looks more like more than 2 months, but it's not completely at scale. After 2 months, you're going to have to multiply by this again. So times 1.083 repeating. And so that would get you to 1.083 repeating squared. And if you went all the way down 12 months, so let me get myself some space here. So if you went all the way down 12 months, so 12 months, or I should say from the beginning 12 months, so another 10 months. So what's the total interest you would have to pay over a year if you weren't able to keep coming up with the money, if you had to keep reborrowing and I kept compounding that interest? Well, you're going to have to pay 1.083 to the, well, this is for 1 month, so you could view this as to the first power. This is for 2 months, so you're going to have to pay this to the 12th power. We have compounded over 12 periods, 8 1/3% over 12 periods. Or if you wanted to write it in this form right over here, this would be the same thing as our original principal times 1 plus 100% divided by 12. So now we've divided our 100% into 12 periods, and we're going to compound that 12 times. So we're going to take that to the 12th power. So what is this going to equal to, this business right over here? So we can get a calculator out for that. So I'll get my TI-85 out. And so what is this going to be equal to? Well, we could do it a couple of ways. And this is 1.083. Let me actually, this is repeating right over here. Let's get our calculator out. So we could do it a couple of ways. Actually, let me just write it this way. You're going to get the same value. And I don't have to rewrite this one here. I just did that there to kind of, hopefully you see this, the kind of the structure in this expression. So 1 plus 100% is the same thing as 1. So 1 divided by 12 to the 12th power. To the 12th power. 2.613, I'll just round. So approximately 2.613. Now you say, well, this is an interesting game. You've almost forgot about your financial troubles, and you're just intrigued by what happens if we keep going this. If we, here we compounded we have 100% over a year. Here we do 50% every 6 months. Here we do a 1/12 of 100%, 8 1/3% every 12 months, and we get to this number. Well, what happens if we did it every day? Every day. So if I borrowed $1, and I said, well, gee, each day I'm just going to charge you 1/365th of 100%. So 100% divided by 365, and I'm going to compound that 365 times. And so you're curious mathematically, and you say, well, what do we get then? What do we get? What do we get after a year? Well, you have your original principal. Let me scroll over a little bit more to the right so we have more space. You're going to have your original principal times 1 plus 100% divided by not 12. Now we've divided the 100% into 365 periods. 365 periods. But we're going to compound it. Remember, every time we have to multiply by 1 plus 100% over 365 every day that the loan is not paid. So the 365th power. And you say, oh, gee, taking something to the 365th power, that's going to give me some huge number. But then you say, well, actually, maybe not so bad, because 100% divided by 365 is going to be a small number. This thing's going to be reasonably close to 1. And obviously, we could raise 1 to whatever power we want, and we don't get anything crazy. So let's see where this one goes. So this is the same thing as 1 plus 100% is the same thing as 1 divided by 365 to the 365th power. And we get 2.71456. Let me put it over here. So then we get, so this is approximately equal to 2, and this approximate is a very, it's a very precise approximation, but 2.7, but my calculator's precision is only goes so far, 2.714565, and it keeps going on and on. And this is really, really interesting. It looks like as we take larger and larger numbers here, it doesn't just balloon into just some crazy, ginormous number. It seems to be approaching some magical and mystical number. And it is, in fact, the case that if you were to just take larger and larger, if you were to take your 100% and divide by larger and larger numbers, but take it to that power, you're going to approach perhaps the most magical and mystical number of all, the number e. And you could see it right over here on your calculator. They have this e to the x, and I can do that. So e to the, I'll raise it to the first power so you can look at the calculator's internal representation of it. And you see just already raising doing 1 plus 1 over 365 to the 365th power, we're starting to get really, 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 really close to e. And I encourage you to try this with larger and larger numbers, and you're going to get closer and closer to this magical mystery. You almost wouldn't mind paying the loan shark $E because it's such a beautiful number.